All right, what I want you to do, take a piece of scrap paper, explain how you know that segment AB is congruent to segment ST. Again, we're going to use, since we're proving segments or angles, either one of those, what are you going to use in this proof? CP, CTC. All right? What do you got to prove before you use CP, CTC though? Prove that the triangles are the same. Write this down, write it on your paper, make sure your names are on your paper, and I'll collect it. All right? And I'm going to do this for you guys because Graham's going to promise me that no matter how boring the rest of the day is, because as we're doing these 2-column proofs and I'm trying to work them up here, I know they get boring. All right? You ain't going to fall asleep. You guys are going to stay on it, right? Because we have a test over this coming up real soon. Not this week probably since we have the shortened week, but next week for sure. We have a test, first test of the 9 weeks. Trevor, do you need the first test of the 9 weeks? Yeah, it'd be nice to get off on a good foot, right? So, follow along. I'll write this down, then we're going to do some problems off of the homework. Then we're going to move on from there, and I'm recording it, so you guys are going to help me out, right? I'm helping you out right now, giving you a free grade. I'll help you. And then you're going to help me out getting the recording done. All right. Somebody help me first off. You look like you're actually awake today. Did your mom call you or something and tell you that I just talked to her? Okay, that's good. Speaking of which, Clayton, I sent your mom an email apologizing. Tell her that I really am sorry. I wasn't thinking. So if she's cussing at me and stuff when you get home, tell her, yeah, Mr. Ebersole said he's been cussed at before, so he doesn't mind that, but he does apologize.
Okay. What does the email consist of?
Me apologizing to her. What are the letters?
A, B, C.
A here, B here?
Yeah.
X, Y,
T.
Z.
What?
W, X, Y, Z.
T, S, C, S,
T.
R.
Oh.
T,
R.
X, R.
R,
S.
S. And what'd they tell us?
I'm
A
bad.
and S are.
Now watch. Angle A is congruent to angle S, right?
Yeah.
Is that enough to say the two triangles are congruent?
No.
How many parts do we need to say the two triangles are congruent? 3, right? Remember, I'm going to write them over here. Side, 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 angle, side, angle, side, angle, 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 side. We need to prove the two triangles. We need one of those 4 things. What else did they tell us?
That C and R congruent.
So angle C is congruent to angle R.
Yep.
And what else?
That segment A, C, and segment S are congruent.
So they told us all that.
Mhm.
Is that enough to say the two triangles are congruent?
Yes.
It is? By what?
Angle, side, angle.
Angle, side, angle. Does it go in the right order for angle, side, angle?
Yes.
Remember, the side has to be between the two angles. Otherwise, if the side wasn't between it, it could be angle, angle, side maybe. But it has to be between for angle, side, angle. So right now, what do you know about these two triangles? They're congruent. That's the first thing that we're going to say. All right, that's the first thing we're going to say. I know the, or let's not say the, I know triangle, name the first triangle for me.
A, C, B.
I heard ACB first, it doesn't matter really. Is congruent to, now be careful, what do you have to remember when you're naming the second triangle?
The same exact way.
You got to match it up, right? What do you got to do to this triangle on the left to match it up to the triangle on the right? Do you flip it?
No, you just scoot it over.
Just scoot it, slide, right?
Slide.
So what's A match up to? S. What's C match up to? R. And what's B match up to? T. So you got to make sure you match them up correctly. I know triangle ABC is congruent to triangle SRT. Is that all we write?
No.
We just know that? Anytime you make a statement, what do you got to do?
Give a reason.
Give a reason. Because, come on in.
Let's do laptops anyway. Me and Katie did.
I didn't even see it. Because what?
Side, angle,
Which one is it?
Angle
Angle,
side.
side, angle.
That's it, sorry.
Angle, side, angle, postulate.
Wait, why do we have to write the ASA postulate instead of just ASA?
Yeah, because we're sort of explaining it out for words. If we were in a two-column proof, then ASA is fine.
Okay,
But-
that's what I was wondering.
But here you're writing it in sentence form. Probably don't want to end the sentence because ASA, because that might not make sense to whoever reads it next. Are we finished?
No.
What they want us to prove, or what they want us to show? What was
That
congruent?
segment AB is congruent to segment ST.
This segment's congruent to this segment.
Yes, it is, because they're congruent, so that means that's side.
So
All sides are the same.
now are all the sides the same? Do we want to say it that way?
No.
All corresponding sides must be the same. And that's what we're going to say. All right, since we know the two triangles are congruent, then we can say, so I know, and again, I'm not an English teacher, so that's not probably appropriate for grammar. So I know segment AB is congruent to, what segment's it congruent to?
ST.
ST, is that all we're gonna put? Now, probably do I wanna put CPCTC in here? Is it- whoever looks at this next, are they gonna know what that means? Ryan's sitting here in class and he's off in his own little world again, so he doesn't even know what it means.
I wasn't even here.
But we've said it like 10 times already.
CBCTI.
CBCTC. CP, no, CP. Why am I'm letting him? CPCTC. I'm letting you tell
That
me.
confuses me.
Look, to remember the abbreviation, C is every other letter, right? So remember that. P and T. What's P stand for? Parts. T stands for triangle. So I actually want to write something out here. I know that segment AB is congruent to segment ST because corresponding sides, what's it mean to be corresponding again? The ones that match up, ones that lay over top of each other, right? Corresponding sides of congruent triangles. So what do you know about corresponding sides of congruent triangles? Are the same. Now in this picture, that's not all we know. Tell me another pair of segments that you know are congruent other than the ones that we already, BC and TR have to be congruent. Tell me a pair of angles that have to be congruent. We already know those.
ST.
Give just one letter is enough.
Angle A and
Angle B and angle T. How many parts do we know in these two triangles? We know all 6 pairs of congruent parts, right? Because we know the two triangles are congruent. All right, make sure you got that written down. Make sure your name's on it. I'll collect it here in just a minute. What I want you to do now, get out your books, open them up to page, what was it, 211? Is that right, 211?
Yeah.
Page 211. On page 211, questions, problems you want to see worked off of page 211. Somebody tell me so that everybody that wasn't here. What was it? Page 211, what? Number?
10, 14,
14,
15,
15, 17, 18, 25, 28.
That was the assignment, those of you who weren't here. Questions, problems you want to see worked?
10.
10? Problem 10.
I have a half of it.
Before I do problem, yeah, I'll just write it over here and I'll erase it. Before I do problem 10, this is a list of things that's got to come from where? Your brain. So when you're looking at a picture, these are things that you should be able to come up with, not from the given information, but just from your brain.
I switched on
Is
you.
that too hard, Riley? Have something come from your brain? Say yes? All right. Number 1, some of the easy things. Should you be able to pick out vertical angles in a picture?
Yeah.
If you can't pick out vertical angles, I didn't say that. If you can't pick out vertical angles in a picture by now in this class, please go tomorrow, see the counselor, tell them you need to sign up for geometry for next year. All right? Because if you can't pick out vertical angles by now in here, something's wrong. That's one of the things you ought to be able to come up with on your own. Next thing, reflexive property. What is a reflexive property? Anything equals itself. So when you have triangles that share a side or share an angle, the main ones that we look at, how many triangles in that picture? 3. 1, 2, and then the big one. Do those 2 smaller ones share that side right there? Is that side going to be the same length in both of them? Yeah. Is it going to be congruent to itself? Yeah. So that's the main one. Be able to pick that out, reflexive property. Third thing, what's this symbol tell us? Parallel lines. Soon as you see that you have parallel lines, everybody listening, soon as you see you have parallel lines, look for alternate interior angles. When you have alternate interior angles, anybody remember? Those were the easy ones. What did they form? A Z or a N. So maybe look for that N. All right? Number 4, and I've been adding to this as we go through stuff. When they tell you something is bisected, what's that telling you? Split how? Into 2 equal segments, or 2 congruent segments, or 2 congruent angles, depending on what's being bisected, right? So bisected, another word there to go along with bisected might be midpoint. Midpoint only works for segments. Bisected works for segments or angles. Those are things you should be able to come up with from here. All right? They don't have to give it to you. Now, they have to tell you that it's bisected, but then from that you should be able to come up with, hey, if it's bisected, I know these 2 things are... longer to make it bigger. Sometimes it works out real well, and then other times like that right there, I hit it 1,000 times and still didn't erase it. I don't know why. I'm not smart enough to figure out why it's doing it. All right, so number 10. Give me a second, I'm gonna write the given information up here and draw the picture. You should be doing the same on your paper there. It's like the greatest drawing I've ever made, isn't it, John? Perfect. Before we even look at this, look at that picture. What's something you can tell me?
Vertical.
You got vertical angles, don't you? So- These angles right here are vertical. We know that they have to be congruent. Is that a pair of angles in our two triangles? Yeah. So right away, we got a pair of angles already. We haven't even started looking at the given information. The other thing I want you to do before you look at the given information, look at what you're trying to prove. We're trying to prove two triangles this time. If we're trying to prove two triangles, when we go to write our two-column proof, when we get to the bottom, are we going to use CP, CTC? That only comes after the triangles. So if we were trying to prove segments or angles, then we use CP, CTC. If we're trying to prove the triangles, that shouldn't even be in our proof anywhere. All right? So just some helpful hints there. What's this first given say?
Parallel. Segment D and J.
Those are parallel. As soon as the things are parallel, what should you look for?
Interior.
Alternate interior angles, right?
Yeah.
So let's do this. Let me change my colors here. We know that this line's parallel to this line. What could we use as a transversal? What touches both of them? Segment DK, so this. Did they make an N or a Z? So what do you know about these two angles right here? They gotta be congruent. That's another pair of angles. I'm gonna put an arrow pointing at this and just put a little note here. Those were because they were alternate interior angles, right? And we're gonna use that in our proof somewhere. Is that enough to say the two triangles are congruent? No. So we need something else.
J.
Alright, now be careful with this. This is where a lot of people mess up. DK bisects. So what's doing the action here? DK. DK is the thing that's cutting the other thing. The other thing is what's being cut into the two equal parts, right? So-
segment E,
So
G.
it bisects JE. So it's bisecting this segment right here. What two segments have to be congruent? EG and GJ. That's a pair of sides. Is that enough? By what? Be careful. Angle, angle, side. To be angle, side angle would have to be the side in between the two angles, right? So it's got to, you got to make sure it goes in the right order. So do we have enough to say the two triangles are congruent? Yeah.
I think side six.
Now, are there other ways you could have done it? Yeah. Side, side, side wouldn't have worked. So you got to be careful on that. But you could have, we could have used these two angles and said angle, side angle. That's another way. I'm going to draw, what did I want to do here? I want to put something there. Remember that was from it being bisected, so just to remind me of that. I go to write my two-column proof. Now part of the thing where if you use side, 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 part of the thing where you probably messed up was right here on this first one. What's this say again? How do we know that? That was given. Is that a pair of sides in our two triangles? Yeah, they are a pair of sides, but did we say that they were congruent to each other? So can I put a little S out here beside this? No. What did that lead us to? Once we knew that those two were parallel, that led us to what? Angle D is congruent to angle K. Is it all right to name all angles with just one letter? Can you name these angles with one letter? No. How come you can name angle D with one letter? If I say angle D,
Well, I guess there's no other.
there's no other angles there, is there? There's one angle with that vertex, so it's all right to say angle D.
There's two
If,
angles there.
if you say angle G,
It could be either one.
could be any of those, right? So you got to be careful of that. Now, how'd you know that angle D was congruent to angle K? All right, and the way we're going to write it is when we had that theorem back in chapter 3, it said if parallel lines, then what do you know? Alternate interior angles must be congruent. That's a key reason that you need to know. You see parallel lines, you're going to use that reason somewhere in your two-column proof. What did I put out here beside the 2? Is that enough to say the two triangles are congruent? Nope. Do the other given? Okay, we can do that. So segment DK bisects segment JE. How do we know that? Given. Do I put a S out here beside that? Are we saying two segments are congruent in the two triangles? No. What'd that lead us to? Knowing that JE was being bisected told us what?
But EG is congruent to
Oh,
You knew that.
I had it down there, I just don't have it where it was.
Segment EG is congruent to what?
JG.
JG or GJ?
However you want to write it. Like the side next to that.
You can put an S out here. Now, the reason. How'd you know that if JE was being bisected that those two segments were congruent? What I just said, right? We'll say something like, if segment bisected, then what's happening to it? Then split into two congruent segments. If a segment's bisected, then it's being split into two congruent segments. Is that enough to say the two triangles are congruent? Got a pair of angles, pair of sides. Is that enough? How many parts do we need? So we're missing one. What are we missing? We're out of given, so where's this got to come from? Got to come from your brain. That could be for yours, but not for mine, because that's not what we marked. Where did we come up with something else from?
Angle K is congruent to angle E.
We already got angle K and angle D.
E and J.
E and J, we didn't do that one. We could have. What kind of angles are E and J to each other?
Same thing as the.
Alternate interior. So we could have used that, but we didn't. So I'm not going to stick it in there now.
But that wouldn't that give us the other angle we need?
Yeah, but that's changing up what we thought it through as already. Then that's changing our whole idea. So we'd have to go back and make sure we did everything else to go along with that. Where did we come up with our other pair of angles from? The middle. The vertical angles. Come on now.
I said that twice.
I didn't hear you.
Say it well enough to get us.
Name that angle on the left for me. Be careful. 3 letters. DGE. Remember the vertex has to be in the middle, right? And that's congruent to
JG.
JGK. Now, part of the reason I'm using the vertical angles and not this other one, do you really want to write that reason over again if you don't have to?
No.
The reason for vertical angles is this. Vertical angles congruent. It's a lot shorter. Try to make it as easy as possible. What do I put out here beside the 5? Is that enough to say the two triangles are congruent?
Yeah. Then you had said,
So are we done?
now you had to prove
What do we write?
triangle EGG is congruent to triangle JGK.
Do we have to match the triangles up this time? They've already done it for us, right? How do we know that those two triangles are congruent? Angle, angle, side. Remember, look back over here, because over here it's in the wrong order, isn't it?
Yeah.
Does it matter it's in the wrong order over here? No, it doesn't make any difference, but the only thing it can do is confuse us.
We decided what we were gonna look at.
What's statement 7 going to be? Nothing.
Because we're not doing any segments or angles.
Since we just went to the triangles, do we have to use CPCTC this time? No, we stop right there and we're done. If this had said, prove that this segment is congruent to that segment,
Then we would have to do.
then we would have had to do 7. And we'd use CPCTC. Next question, another question off 211. 15? How about if on 15 this time, I just draw the picture and I don't write all the given and stuff up here? You guys can help me out, right? And I did call your house, Jonathan. I told him how much smarter your sister is than you.
I think I'm doing pretty good.
You are today. That's why I figured. When you came in here and you were all bright-eyed and everything, I figured his mom must have told him. That's correct. What's the first given tell us? How many triangles we got here? 2. What are we trying to prove so I don't have to look back at my book?
Angle NOM, not NO, segment MO is congruent to OR.
So MO congruent to OR, these two right here.
Yeah.
So that's a pair of segments. So what are we going to have to use in here? So we know at the very end we're going to use CPCTC. So we'll write that down there. What's the first given tell us? So this angle is congruent to that angle. Are those vertical angles?
No.
It's wrong look, isn't it?
Yeah.
So make sure you don't think that. A lot of people look at those and say, oh, those are vertical angles. No, vertical angle's got to be where two lines cross, not that little jag in there. So that's a pair of angles. Is that enough to say the two triangles are congruent? All right, what else? Say it again.
NO.
Segment NO is congruent to segment PO. Is that right? So I mark those. That's a pair of sides, right? Chris isn't lying to me, is he? Because you guys are all acting like he doesn't know what he's talking about. Is that one of the givens? It's not?
I don't think so.
Chris, did you lie to me?
I'm a liar.
What did they tell us?
Segment
They
ER
are sides, though.
is parallel to segment
Parallel?
perpendicular.
So-
Why is it parallel?
MN is perpendicular to that, right? So what's that tell us about this angle right here? Remember, perpendicular means what? They intersect at a 90-degree angle, so we know that that right there is a right angle. Somebody name that angle for me.
Angle,
Angle NMO. We know that's a right angle. We're gonna need that somewhere in our proof. What's the next given say?
Segment NM is congruent to segment PR.
I think we skipped one.
Yeah, we did.
No, I said that.
segment NM is,
PR.
perpendicular to segment MR.
So what's that tell us about that angle right there?
That's a right.
Somebody name that angle for me. PRO. We know it is a right angle. Well, if those two are right angles, what do you know about them? They're congruent. So somewhere in our 2-column proof, we're going to say that. That's another pair of angles. We'll put the angle over here, since we already put one over here. What's the next given say?
Segment NM is congruent to segment PR.
So this segment is congruent to that segment. Are those two in our triangles? So that's a pair of sides. Do we have enough now to say that the two triangles are congruent?
Yes.
What's our reasoning?
Angle,
Angle, angle, side. Are we gonna be finished once we get to angle, angle, side? No, then we're gonna have to use what? CP, CTC. Good. See if we can write this without anybody lying to me or telling me the wrong thing.
That was my fault. I'm sorry.
What's our first statement gonna be?
Angles NOM is congruent to angle POR.
Angle NOM is congruent to angle POR.
Yeah.
How do we know that? Were those angles in our two triangles? So I put an A out there. We got a third of what we need, right? Got a pair of angles. Now what? Let's do the segments next. What were the two segments that we knew were congruent?
And NM
It's congruent to PR, segment PR. How do we know that? Given. Now, I didn't do that for any other reason than that one was easier than the others, right? Pair of sides. Do we have enough to say the two triangles are congruent? No, we need 3 parts, right? Not just 2, 3. Are we out of given? What else do we have?
segment NM is perpendicular to segment MR.
Now, before we go on, because I want to be lazy today, and then let's go ahead. How'd you know that? Are we out of given now? What's the next one say?
Segment POR is perpendicular to segment MR.
Segment PR,
Yeah.
perpendicular segment MR. How do we know that? Now, you probably shouldn't have done this, because we skipped right over this one. Because did that tell us something else? Yeah, as soon as you know things are perpendicular, what should you be looking for? Right angles, 90-degree angles. So from this first one, which angle's a right angle? NMO is a right angle. From this second one, I'm going to write this all as one because I'm going to be lazy. From this second one, which angle did we know was a right angle? Angle PRO is a right angle. So, if this is perpendicular to that, we know that that's a right angle. If this is perpendicular to that, we know that that's a right angle. All right? How do we know that? I just told you. Because they were perpendicular. And all you're going to write, perpendicular lines. Perpendicular lines form what?
90 degree.
right, 90-degree angles, I'm gonna say right angles. Perpendicular lines form right angles. Do I put an A out here beside that? What do you gotta say before you put an A or S out here? You gotta say that the two things are congruent. Well, once I know that that's a right angle and that's a right angle, guess what you can say about them? They're congruent. So angle NMO is congruent to angle PRO. And we haven't talked about this reason yet. I'm not erasing that line. We haven't talked about this reason yet. But what do you know? If this is a right angle and this is a right angle, what do you know about them? They're congruent. That's what the theorem says. It's the second shortest theorem in the book. Guess what the shortest theorem in the book is? Vertical angles are congruent. And this one says all right angles are congruent. That was a pair of angles, right? Do we now have enough to say the two triangles are congruent? Yeah, we got three parts. Now here's where you got to be careful again. Do we do CP-CTC right now? You got to do the triangles first, then CP-CTC, right? It wouldn't. I would have had it done 20 minutes ago if it was just me doing it on my own, but trying to teach it to you guys, it takes a while.
Still ain't working for me.
Huh?
It said it still ain't working for me.
Number 7. Name the triangle on the left for us. M-N-O, is that what you said?
Yeah.
Oops, I forgot my triangle symbol. Now you got to be careful. What do you got to do to this triangle to match it up to this one? You got to flip it. All right?
Yeah.
What's the M match up to?
R.
R. What's the N match up to? P. And what's the O match up to? O. How'd you know that those two triangles were congruent? Angle, angle, side. Please remember, if you put triangle something congruent to triangle something as a statement, what's the only thing that can be here as a reason? One of the 4 things. Side, 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 angle, or angle, angle, side. It can't be anything else out there beside the triangles. It's got to be that. Are we finished?
No, you didn't prove.
What's our last reason over here going to be? As soon as you're done with that, if you got another reason, corresponding parts of congruent triangles must be congruent. It's got to be that. It ain't going to be anything else ever. What were we trying to prove?
Segment M is congruent to segment O.
Chris, give me another pair of segments in that picture you know are congruent now.
Anything?
That you know are congruent, yeah. Why did I call him Chris to do this?
Because I got one earlier.
Because he told me him earlier and
Not
I
loud.
remember.
didn't have anything to do with the problem.
NO.
Segment NO is congruent to segment PO. Now we know Chris isn't a complete liar because now it's true. Give me another pair of angles that we know are congruent. Anybody? Angle N has to be congruent to angle P. So we now know that this angle is congruent to that angle. Other questions? We're going to go through this very, very quickly, so you better write quickly. Problem 18. They give us this picture.
Which one did you say?
18. many triangles in this picture? 2. What's these arrows tell us? Parallel. So as we see that we have parallel lines, what should we look for? Alternate interior angles. Does everybody see those 2 angles? What do we know about them? They're congruent. They're alternate interior angles. That's a pair of angles, and they're alternate interior angles. We'll use that in our proof somewhere. Is that enough to say the 2 triangles are congruent? No. Give me something else that they tell us in the given information, so I don't have to look back at my book. You got that one?
TX1 is congruent to TS1.
So TXY, that's this angle, right?
Yeah.
It's congruent to TSY. Is that another pair of angles in our 2 triangles? So we got angle, angle. Is that enough? We need a side, right? Right up the middle. What do you mean right up the middle?
But they're,
What do you know about reflexive property? Segment TY is congruent to what? Segment TY. How come it's congruent to TY? Reflexive property. It's the exact same segment, right? Is that enough to say those 2 triangles are congruent now? Yeah. By, be careful now. Angle, angle, side. What are we trying to prove? We trying to prove the 2 triangles?
Yep.
We are?
No, segments.
Oh, is it segments?
Yeah.
We're trying to prove that.
Triangles, yeah, we're putting triangles.
So do we have to go any farther than angle, angle, side? No, that's it, isn't it? We don't have to go to CPCTC. So let's write this real quick. Statements, reasons. First statement, what was it? TX is parallel to SY. That was given. Once you know things are parallel, what do you look for? Alternate interior angles, which is angle, again, make sure 3 letters. XTY is congruent to angle TYS. And we knew that because if you have parallel lines, then, oops, forgot then alternate interior angles are congruent. That was a pair of angles. What was the other given? Angle TXY. Is this angle TXY the same angle as XTY up here? No, they're 2 different angles, isn't it? It's congruent to which angle? TSY? How do we know that? It was given. Another pair of angles. We're out of given information. Where do we go to next? One that you ought to be able to pick out every single time, right? They share that side right there. So segment TY has to be congruent to segment TY. Somebody tell me what the reflexive property says again. Oops. Anything equals itself. Good. Anything equals itself. Pair of sides. Is that enough?
No, we gotta do the proof.
I mean, is that enough to prove the 2 triangles?
Yeah.
Did they already name the triangles for us?
Yeah.
So do we even have to match them up ourselves? No. What'd they tell us? Triangle what?
TS1 is congruent to YXT.
Now watch, before I write the second one. What would you have to do to this triangle to get it to match up to this one? Be careful.
That's that.
Does it flip? Just flip over like that?
No, you gotta flip it and
It's gotta rotate around,
rotate.
right? So T in this bottom triangle is actually gonna match up to Y in the other triangle. You gotta be careful of that. What was the other triangle? YXT. How do we know that those 2 triangles were congruent? Angle, angle, side. Let's go through this just real quick. How many points if this was on a test? 10. Count up, how many should you get? no matter what.
Five.
I see four, five,
If you only get 4, then you're not trying very hard.
Five, six.
six,
I see 10.
Should you get this one?
Yep.
Yes.
Yep.
Yes.
That's 2.
Maybe missed that one.
Yeah, maybe you missed that one.
Maybe missed that one.
How about this one?
Yes, you get that.
Should get that.
You get that.
That's 4.
Yeah.
Should you get this?
Yeah.
Yeah, you should.
That's 5,
Yep.
Yeah.
6,
Seven.
And you
7.
have 25% chance of getting that.
25% chance of getting that right. So you got 7 out of 10, which is what?
Possibly.
70%. That's not a C, but it's a D, but 70% is pretty good. It's better
Time
than,
for one
Better
more,
than
you
nothing.
get a C.
it's better than a lot of the grades that I've seen this past 9 weeks.
Mine was better than that.
Like,
No, it was. I had a 7:30.
All right, write this down.
You want a paper?
Can't read this. Oh, pass those. Pass them all to your left. Pass all those papers to your left. This is the start of your notes for today. Skip a line in between each one, or a couple lines in between each one. We're going to go over this very, very quickly because we're not really going to use this a whole lot. All right, I just want to show it to you so you've seen it, and then we're going to move.
makes sense.
All right, on this, proving right triangles are congruent. And again, we're not going to use these because you already know side, 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 angle, side, angle, and angle, angle, side. And all of those, or one of those, will work for every one of these. And we just did a problem that had right angles in it. Now, what it would have done, it might make a difference to Bryant sitting back here because it would have made his 2-column proof 1 step shorter. And that might just make his day if his 2-column proof's 1 step shorter. If it does, then Bryant, I feel really sorry for you
Makes my day every time.
if losing 1 step excites you, then wow.
The less math I have to do, the more happy I am.
Then I feel bad because when somebody was calling you lazy the other day, I was thinking, he's not lazy, he's just inconsistent.
Don't put the effort into it.
There you go.
But if 1 step excites you, then I might have to go back and rethink my.
I'm trying to get the ball.
So we got these 2 triangles, and we know that they are right triangles. What's it mean to be a right triangle?
It's right.
It's got 1 right angle in it. In a right triangle, I'm going to draw this over here just in case anybody didn't know. In a right triangle, the side that's across from the right angle is called the what?
Crap.
Hypotenuse. It's called the hypotenuse.
Dang.
What are the other 2 sides called? Legs. All right? If you didn't know that, it was written up here as you were writing this down, right? You could have probably used that. What do you think this theorem says? What do we need to know?
They have to eat the leg have to be the same.
So this leg has to be equal to that leg, and this leg has to be equal to
That leg.
that leg. Now, what I'm saying is, we don't really need that theorem. We could use it and make our 2-column proof 1 step shorter. What could you use here? Which one of these 4?
Whatever. Side, side,
That one.
whatever.
You always get right to the same side.
Oh, side, side, side. Angle, side, side.
All right, let's look at it again. What do we have here?
Side.
Side,
Angle.
angle,
Side.
side. Which one of these could we use?
That side.
Side, angle, side. So we could use side, angle, side on that and not have to even worry about the leg one. Now, if you wanted to use the leg one, go right ahead. All right? All it's going to do is in your 2-column proof, You're not gonna have to say that this right angle is congruent to that right angle. You're just gonna have to show that they are right angles, and then not have to do that next step where you said they're congruent to each other. That's sort of what I figured, that's why we go over this so quick. How about on those? What's hypotenuse angle?
Whatever I say.
What do you think you know if you're going to use hypotenuse angle? You know that the two hypotenuse are what? Congruent. So that,
They're congruent.
and you know that any pair of angles are congruent. So let's say this angle is congruent to that angle.
So it's side angle side. That's the problem.
So this one would fit angle, angle, side. So if you wanted to use hypotenuse angle, you could, but it also is going to fit angle, angle, side, and you could just use that. So in other words, what I'm telling you is, do you really need these other four if you already know these? No. Maybe down the road, when you're better at math, you've been doing it for a long time like I have, then you start using those because it makes it just that little bit shorter. Otherwise, for now, those four are probably good enough. How about this one? What would we need in this one? Got two right triangles. Boy, those look terrible. Look, don't tell me what it matches up to. Just tell me what we need.
Leg,
Pair of legs, so maybe that, congruent to that.
and then
An angle, maybe this angle congruent to that angle.
angle side angle.
Angle, side, angle. Now, if you would have picked this angle instead, and this angle, then instead of angle, side, angle, it would have been angle, angle, side. But it's still, we know another way that we could do. I'm going to draw this up here because I'm out of room down there. Hypotenuse leg. What do you need on this one? The hypotenuse are congruent and a leg are congruent. Which one does that match up there? Side angle side, does it match that one? It's not in the right order, is it? Side, 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 angle, angle, side. Which one does it match up to? Angle, side, side. Whose theorem was that? Was that Brian's theorem?
Yeah.
Or was that Riley's theorem?
No, it was Brian's theorem. That's right.
That was Brian's theorem, angle, side, side.
Yeah.
Does it match up to any of them?
Now,
No, so this one is sort of an oddball. If this is the information that you had, then you would have to use this. All right, because otherwise it doesn't fit anything else. And the reason it works for right triangles, but it doesn't work. So when I said Bryant's theorem didn't work, I sort of lied to you, because it does work for right triangles, but it doesn't work for any other triangle.
so I can use.
All right? Only if you have right triangles.
Only fucking.
And then you don't write it angle side side because it's going to be what? H L instead.
So HL.
All right. The reason this one works is because Pythagorean's theorem works. And if you know this side's congruent to this side and this side's congruent to this side, what can you say about the other two sides? They have to be congruent because Pythagorean's theorem. Right. Go ahead and copy this down.
And then we do not turn the light off.
Nah, I don't want to mess with things today.
What the?
Did you hear me? Do not turn the light off.
I'm not going.
I would walk over there.
They wanted me to do something mean to you, Clayton, and I said, nah, because I know Clayton's gonna be a nice guy and pick up all that little trash that he threw around my trash can before he leaves, and then I was just looking at while ago, it worried me because his binder, look, 9 weeks has sort of been a
I
crappy
know it's
grade.
around two.
So, this is something that he could do a whole lot better on,
I know around what time it is when I'm
because it's not hard to just write, is it?
Or you'd be like, Mr. Swafford, give a volleyball, drop it.
He does that every morning, like he will.
What
Well,
happened?
You do it a couple times while you're asleep.
Yeah,
He
you'll be,
just release,
yeah.
drops it.
Drop it on the ground.
He'll drop it right on the desk. It's like, dude, I was not ready for that. I'm sitting here taking notes.
it's not gonna break his desk.
Shit.
Bowling
Do
ball
you
is
set
break my
random
desk.
things on fire, like
Oh,
you set
right,
like
right,
flags
right
and
there.
everything on fire?
All right, what we're going to talk about today, isosceles triangles. What is an isosceles triangle?
Two sides that equal.
All right, a triangle that has at least 2 sides equal. You'd be able to use the properties of isosceles triangles, some of which we've already used, and also a little bit about equilateral triangles. Now, what we're going to talk about with equilateral triangles, I'm going to go ahead and draw an equilateral triangle here. If I tell you that triangle is equilateral, tell me what you know about it.
All the angles are.
That's all the sides are equal and all the angles are equal, and somebody else even went a little farther. What do you know about all the angles?
Legal 180.
They add up to equal 180, so tell me what this angle is. 60 degrees. That, I would draw that right there in your notes right now. If you see a triangle and it's equilateral or equiangular, you know all that information. You know all the sides are equal, all the angles are equal, and you know that every angle has to be 60 degrees. So if I gave you a picture like this, and I told you that, and I said that that right there was 2x plus 4, so what equation could you set up?
2x plus 4 equals 60.
2x plus 4 equals 60, and you could solve for x just from that. You don't need anything else. All right, with an isosceles triangle, some things you probably learned in the past about an isosceles triangle. Go ahead and draw this picture. What's those 2 tick marks tell us? Those sides are what? What are they? Congruent, equal.
Parallel. Same thing.
No, parallel means this.
Okay, parallel lines are the same, aren't they?
Not always.
Yeah, but those.
Lines
parallel
aren't never the same because you can't measure a line.
Parallel lines never connect to.
Because lines go one on
Correct.
one.
So these can't be parallel. So these 2 are congruent. All right? Now, in this, we know that these 2 are congruent. Does anybody know what any of these other parts are called? Or any of the parts in an isosceles triangle are called? You got a base, that's true. Any idea where that's at?
On the bottom.
Now, does it have to be on the bottom? If I tell you this is an isosceles triangle, and I turn it upside down like this, is the base on the bottom? No, so don't get that in your head and think that that always has to be
The
that way.
base is usually the one that is not.
It's usually the
It's
shortest.
It's the one, now it doesn't have to be the shortest, but it's the one that's not the same as the other 2 in an isosceles
It could
triangle.
be the longest one, but.
Anybody have any idea what these angles are called?
No.
All right, so watch, now we'll show you. Write this down. You told me this was the base. Well, the 2 angles that surround that are called the base angles. Now, the reason the base angles are important, if I know these 2 sides are congruent, guess what's true about the angles across from those sides? They're congruent. So what do you know about the base angles in an isosceles triangle? They're always congruent to each other. They're always congruent. Anybody have any idea what this angle up here is called?
Vertex.
The vertex angle. What are you doing, looking at it online?
That's what I've been doing.
So how'd you mess up that other one?
I wasn't looking.
So that's called the vertex angle. Now with the vertex angle, if I told you this vertex angle was 40 degrees, could you find the other 2 angles in that triangle?
Yeah.
Yeah, what would you do?
Minus 780.
180 minus 40,
And divide by 2.
divide that by 2. What's that give you? 70. So each one of those angles has to be 70 degrees. A real common problem there. What'd you tell me this side was? That's the base. Make sure you write that in there. Again, does the base have to be on the bottom? Make sure you don't think that. That's what everybody thinks. As soon as I give you an isosceles triangle and I stand it up here and I say, where's the base? Everybody, right there on the bottom. No, that's not the case.
Right there on the side.
Anybody have any idea what these other two sides are called? Legs. Good. What do you know about the legs in an isosceles triangle?
They're usually long.
They're always what?
Equal.
They're always equal. They're always congruent to each other. So you know the base angles are always congruent, and you know the legs are always congruent. All right, the isosceles triangle theorem. I don't really want you to write this down because you're going to write it. Write this part down, isosceles triangle theorem. This is what it actually says. If two sides of a triangle are congruent, then the angles opposite those sides are congruent. This is what I want you to write down. If, I'm going to put the shortened form up here. If, what do you think that says?
If triangle equal triangle.
If triangle has two congruent sides, then what do you know about those two then? Then those angles must be congruent. Right? That's the isosceles triangle theorem. That's the shortened form of it instead of this. A lot shorter here. What would the converse of that be?
If the congruent, whatever the term, then
If congruent what?
the
Angles are congruent,
and
then what do you know?
the sides are
Then the opposite sides have to be congruent. Write both those down.
okay.
So in a triangle, if you know two sides are congruent, then you know the angles across from them are congruent. If you know two angles are congruent, then you know the sides across from them are congruent. So what do you think happens in a triangle if you know all three sides are congruent?
All three.
All three angles are congruent. We just talked about that with equilateral or equiangular, right? And that's where that comes from, is from that theorem right there. Equiangular, we already wrote this down just real quickly. What's this angle? 60 degrees, this angle? 60, this angle? 60, how long is this side?
Some odd number.
Some number we don't know, right? But if you knew it was 12, how long would this side be? 12, 12.
Oh yeah.
All right, we got 10 minutes left. What we're going to do,
Show some examples on the board.
you remember those examples? Or I'm sorry, remember those worksheets that we passed out last time? We're going to go back and we're going to do a problem off those so you can write it down in there. This is your assignment, so I'm going to get that out of the way.
Brian needs one of
Yeah,
those.
could I get one too, please? I
Papers.
said please.
What papers?
They did it. They're like,
Oh, okay.
At least I asked.
I think these are-
Put that sign up.
I think it's
Brittany
like-
Prince.
missing.
I just got tired of people being
You
annoying.
talking about this paper?
Yeah. Yeah, well, those two, there was two of them.
I have those, I just need one of these.
Yeah.
There it is.
Remind me at the end of class that I'll get you.
There it is. I got
No,
it.
both of
Those
them.
are yours.
I got it.
All right, let's, since we only got like 10 minutes, we probably only got time to do one problem. So let's pick one where you have to use CPCTC. I don't care which one it's off of, just find me one where we have to use CPCTC.
Number 3?
3 on which one? The one that starts with CPCT,
Yeah,
C at the top, or the other one?
Like that.
This one?
CPCTC one.
Did we do that one last time?
I don't remember.
We did number 3.
Yeah, we
You got that, you know that right
So pick me a different one.
now. It's easy.
How do you know if you're using CPCTC on it?
When it's not the triangle.
When you're not trying to prove the triangles.
So it's number 6.
Number 6 on that same page?
Yeah.
Number 6 on the same page. Again, write this down so you got this. Remember, these go in your notes. This is number 6 off the page that says CPCTC. It's on the back side. I'm not going to write the given and everything because we don't have a whole lot of time. I'm just going to draw this. How many triangles in this picture?
2.
2.
You have to look for the interior exterior angle or whatever.
Let's see. It tells us angle Q is congruent to angle S. Is that a pair of angles?
Yep.
Yep. Angle TRS, that's this angle, is congruent to angle RTQ, that's this angle.
Isn't that what
It's
we're
another pair of angles.
So that's the angle, alternate interior angle. right?
Now, it could be, but did we have parallel lines? No. But what you could do, since you know these two angles are congruent, guess what you can say about these two segments here? That they are parallel, going backwards. Now, that didn't help us with what we're trying to do, but, all right, that's something that we could do, going backwards.
Could you do the bisect?
That's all we got. That's all the given.
Could you bisect middle?
What do you mean?
Like angle bisect? Reflective.
Reflexive property? What do you know about segment TR right here?
There, congruent to itself.
It's congruent to itself. It's in both triangles, isn't it?
That's what I'm
Is that enough to say that these two triangles are congruent?
Yeah.
Yeah, by what?
Angle.
Once we know those two triangles are congruent, what can you tell me about that segment and that segment? They're congruent because of
CP.
CP, CTC. So we should be able to write this real quick. First statement was that angle Q is congruent to angle S. How do we know that? It was given. That was a pair of angles. Then what do we say next? Where do you go to if you don't know what you're going to do next? Go back to the given. Angle TRS is congruent to angle RTQ. How do we know that? That was given. That's another pair of angles. That's all the given. So now what do you got to do?
The work.
You got to come up with something from your head. What did we come up with? What are the things you should look for?
The vertical angle.
Vertical angles, reflexive property, parallel lines, bisected.
That reflexive property.
Which one do we have here?
The TR is congruent to TR.
Segment TR is congruent to segment TR. How'd you know that?
Because I'm smart.
We know that's wrong. Reflexive property. That was a pair of sides. Is that enough to say the two triangles are congruent? Yeah. Be careful. Name the triangle. Not be careful on this first part. Name the triangle up top here for me. Triangle what? QTR. That'll work. Now here's where you got to be careful. What do you got to make sure you can do? Got to match it up. What's Q going to match up to? S. Everybody watching, make sure you understand this. What's T match up to? T here matches up to what? R. See how they're marked the same? And what's R up here match up to? T down here, right? How'd you know that those two triangles were congruent? Ah, never.
No, no.
Remember, it's got to be one of those four, right?
Angle, angle, side.
Angle, angle, side. It's got to be one of those four things.
I'll go ahead and put it in.
Now what?
I'll go ahead and put it in. And the CP.
What's our
The groove, gotta go with the groove.
segment QR is congruent to
Yeah.
segment ST? How do we know that? CPCTC. Corresponding parts of congruent triangles must be congruent. This would be worth 10 points. Could you come and write in This last statement, very first thing,
Yeah.
yeah, if it's segments or angles, then you know your reason is going to be CPCTC. All right? How many points should you get on this one?
6.
100.
You should get 1, 2, 3, 4. Should anybody miss this one?
No.
5, 6. Should you miss this?
No.
No.
7, maybe you miss that. Should you miss this?
No.
8,
No.
9 out of 10, 90%.
Did you
9 out of 10 you should be able to get without any trouble.
go through